In this module, we're going to continue looking at nomenclature of ionic compounds. So I want to remind you what ionic compounds are. They are homogeneous substances composed of more than one element, one being a metal and a nonmetal. Today, we're going to look at polyatomic ions, which are ions that are formed of multiple atoms. For the cations, there are really only two polyatomic cations we need to worry about. The first one is NH4 with a charge of 1+, and that is ammonium. That is a very important one for you to memorize because we do use that one a lot in our work in honors chemistry. Second one is H3O with a charge of 1+, and that's the hydronium ion. We don't use that so much first semester, but that becomes really important second semester during our acids and bases unit. So you might as well start learning it now. For the anions, there are many different anions, and that's really what the focus of this is going to be. So we're going to be looking at polyatomic ions, the anions. And the first category are called oxyanions, which is an ion formed by adding oxygen to another element. And when we try to name it, the name starts with the root of the non-oxygen element. So if there is chlorine in there, it gets the root chlor. If there's phosphorus, it gets phosphate. If there's sulfur, it gets sulf. And then the name is going to end with a suffix based on the number of oxygens that are present in the ion. Now as we're doing this, we're going to look at our periodic table. Most of the oxyanions are formed by adding oxygen to nonmetals. So we're going to look at the nonmetals, realizing that the noble gases, the column on the far right, don't form compounds, so we're going to ignore those. We're going to divide the nonmetals into two categories. The inner nonmetals, which are phosphorus, sulfur, arsenic, selenium, and tellurium, and you can see them in that shaded area. For the inner nonmetals, if the oxyanion has the suffix ate, it means there's going to be 4 oxygen. So sulfate would be SO4. If it has the root ite, then it will have 3 oxygen. So sulfite would be SO3. The other category of the metals, or nonmetals, would be the outer nonmetals. And the outer nonmetals kind of form a ring around the inner nonmetals. And that's boron, carbon, silicon, nitrogen, oxygen, fluorine, chlorine, bromine, iodide, and astatine. And the rule is that the outer nonmetals get 1 less oxygen than the inner nonmetals. So if we're looking at chlorine, and it has an 8, there would be 3 oxygen. So chlorate would be ClO3. If it's ite, then there's 2 oxygen, so chlorite would be ClO2. Other prefixes that we can add to our oxyanions are the prefix hypo. If you see the prefix hypo, that means you take 1 oxygen away from what the name normally would have. You see the prefix per, that means you add 1 more oxygen to what the name would normally have. Then we can also add the prefix bi or hydrogen, which says we're going to stick a hydrogen at the front of the compound, and the charge is going to get more positive by 1 factor. As long as we're talking about charges, oxyanions will have the same charge as a monoatomic ion with the same element. So before we mentioned sulfate and sulfite. Well, sulfide has a charge of -2. So sulfate and sulfite both would also have a charge of -2. When we talked about chlorate and chlorite, well, those are related to chloride. Chloride has a charge of -1, so chlorate and chlorite would also have a charge of -1. The only exception to this is nitrogen. The nitride ion has a charge of -3, but all the nitrogen oxyanions, the nitrate and the nitrite, all have a charge of -1. So let's practice seeing if we can name some oxyanions. We've got PO4 with a charge of 3-. The non-metal element is phosphorus. The root of phosphorus is phos, so it's going to start with a phos. It is an inner non-metal. As an inner nonmetal, if there are 4 oxygen, it gets the suffix ate. So this would be the phosphate ion. Hypochlorite. If I look at the root is chlor. That means we're dealing with Cl. So there's got to be Cl in the name. Cl is an outer nonmetal. If we have an outer nonmetal that ends in ite, that means there are 2 oxygen. So that would mean ClO2. But we have the prefix hypo, which means there is 1 less oxygen, so that ClO2 just becomes ClO. Then we need to look for the charge, and chlorine has a charge of -1, so hypochlorite would have the same charge as the root, so that would also be -1. So hypochlorite would be ClO with a charge of -1. The rules help us get most of the polyatomic ions, but there are some that don't follow the rules and just need to be memorized. And those include acetate. Acetate has 2 different ways to write it, but if you look at the formula, there's 2 carbons, 3 hydrogens, and 1 oxygen. One is an organic way that is more structurally driven, and one is an analytical way that is just the numbers. I don't care which one you use, but you need to recognize the acetate ion because we do use it a lot in this course. Cyanide is Cn with a charge of 1 minus. Not that important for this course. We don't use the chemical in our problems or in lab. Hydroxide, OH with a charge of -1. Really important. We use that a lot. Hydroxides are what identify a compound as a base. So in our acid-base unit, we will use a lot of hydroxides. Chromate, CrO4 with a charge of 2 minus, and dichromate, Cr2O7 with a charge of 2 minus, are important compounds when you get to AP chemistry. We don't use them that much in honors, but they do become very important in AP. And then there's a couple that follow the rules for number of oxygen, but you need to memorize the charge. Carbonate is one of them. Carbon is an outer nonmetal, so the H says there are 3 oxygen, which follows the rules. But we don't know of a charge for the monoatomic carbon ion, so we just need to memorize the one for the oxyanion. And carbonate is going to have a charge of 2 minus. And then we talked about nitrate before. It has a charge different than its monoatomic ion, and the nitrate has a charge of 1 minus. And nitrate is perhaps the most common polyatomic ion that we will be using. If you don't want to follow the rules and you just want to memorize the ions, this is a list from your textbook. If you memorize the ions on this list, you will be able to work at a high 4, low 5 level throughout the entirety of this class. Putting ions together into compounds is the same as putting monoatomic ions together. Ions are ions. The only difference is if you're putting a subscript around a polyatomic ion, you need to put the entire ion in parentheses so that you see that the subscript applies to everything. So let's look at ammonium sulfate. From this lesson, we learned that ammonium is NH4 with a charge of +1, and we learned that sulfate is SO4 with a charge of 2 minus. It takes 2 things with a charge of +1 to balance a charge of -2. So in order to do that, we have to have 2 ammonium and 1 sulfate. To show that, we put the ammonium in parentheses and put a 2 subscript. That 2 applies to the nitrogen and to the 4 hydrogen. So the correct formula for ammonium sulfate would be NH4 subscript. In NH4 in parentheses, subscript 2 SO4. Iron 3 chlorite. From a previous module, we learned that iron 3 has a charge of 3+, so it's Fe with a charge of 3+. From this module, we learned that chlorite is ClO2 with a charge of 1 minus. It takes 3 things with a charge of 1 minus to balance 1 thing with a charge of 3+. So we have to put that chlorite in parentheses and give it a subscript 3. So we get Fe parentheses ClO2 close parentheses subscript 3. And that would be the formula for iron 3 chlorite. If we're given the formula like K3PO4, I see that there are 3 different atoms in there, so one of them has to be polyatomic. The K is our cation. That is a metal. I recognize that as a cation. That's going to give us the name potassium. The PO4, following the rules, there is an oxyanion because I see the oxygen, its root is phosphorus. Phosphorus is an inner nonmetal, so the 4 oxygen means it's 8, so it is a phosphate anion. So the name becomes potassium phosphate. This ends the module on polyatomic ions.